Good afternoon, everybody, and welcome to another Procon Know-How episode. My name is Jacobus Oberholster. I'm an AEC and Procon technical consultant with Micrographics, and I will be taking you through this short but interesting clip dealing with how to resolve a unique but painful error in SUMO. So I've got my model open up here or opened here, and if we go to settings, we can see our analysis type is set to linear, and if I click on solve, you'll see that the analysis runs without any problems. However, because this is a steel structure, I'm interested in the effect that sway will have on the analysis, and therefore I change it to, or set it to, a second order analysis, which is becoming mandatory, or rather is essential for designing your structural steel models. So go to second order, I hit solve, and this happens. So analysis did not complete successfully. See the output table for details. If I go to output, I'll see that there's an MKL library reported Pardiso error, zero pivot, numerical factorization, or iterative refinement problem, output not reliable. Okay, so that's quite a mouthful, but it doesn't tell us a lot. And so I've actually written two blogs that deal with this particular error in depth and provide you with some workflow options. But today we'll look at a very unique approach that can help you resolve that issue, because this issue or this error can tell you something about your model and help you to design a better model. So first off, if this error pops up, the first thing to do is to run a buckling analysis, because if any of your elements fail in buckling, it will throw up, or it will, throw up, but it will give you this error if you try to run a second order analysis. So we're going to switch to buckling, hit apply and OK. And if I click on solve and the analysis runs smoothly, then I know that my issue is that one of the elements or multiple elements are buckling. All right, if the analysis does not run smoothly and I get the same error again, it's a different problem that we will deal with in future videos, but my blogs do cover those problems as well. And hit solve, save, and there we go. The analysis ran smoothly. So if we go to results, the first thing you'll notice for combination C1 and mode 1 is that the buckling factor is less than 1. If the buckling factor is less than 1, it means you have elements that are buckling or failing in buckling. Okay, so I can go through my different mode shapes, and a negative mode shape is not something, or a negative buckling factor is not something to worry about. All right, so if the buckling factor is less than 1, but let's say larger than 0 or not negative, that's where an element fails in buckling. If I go to C2, I can see, okay, there's nothing to worry about. But for C1 and mode 1 and 2, I can see that those factors are less than 1. So the program does not highlight or isolate the elements that are failing, but it does give you this buckling shape. It looks a lot like a deflected shape that can indicate where you are experiencing problems. Okay, so these trusses are the problems, and we can start by looking at modifying these trusses. So I can go back to standard, and there's quite a few components here. So I can modify the verticals, diagonals, or the chords. Now I'm going to start off by modifying both the top and bottom chords. So I've named them appropriately here. I'm going to right click, replace section, and I'm going to change these to 80 by 80 by 8. I'm going to do the same with the bottom chords. Okay, so those chords are now larger. I'm going to solve. Go to results, and we can see immediately our buckling factor is larger than 1. And again, the negative buckling factors are nothing to worry about. All right, so all of our buckling factors are larger than 1 or negative, which means that we don't have any elements failing in buckling. So now, if this worked, we should be able to go to our settings, select the second order analysis type, and run our analysis successfully. And there you go. The analysis has run successfully. We can look at our displacements, our reactions, beam forces, etc. All right, so I hope that really helped. Just give you a bit of a guideline as to what to do with that MKL Pardiso error, and that actually to check your buckling will be an important part of especially your structural steel workflows. So I hope you enjoyed this clip. If you have any comments or any questions, please pop them in the comment sections below, and don't forget to like and subscribe for some more content. Thank you so much for watching, and see you in our future videos.